Okay, in this video example, we are going to interpret the graph. So we're going to do an application problem using standard form. So in this graph, we have the function over here already graphed. We have this equation that's comparing the profit a company earns for selling headphones at different prices. What's the maximum profit that they can earn? Okay, so let's keep that in mind, and we're going to go through and interpret some stuff. So first thing, the x-axis is telling us that's the selling price. The y-axis is telling us that's our profit. The maximum y value of the profit occurs at the vertex up here at the top. Problem is, we know it's a little past 6,000, but it's really hard to tell where it's at. So it's really good that we can actually calculate it using our formula. So we're going to go figure out the vertex by doing negative b over 2a. So negative, we got 700 over 2 times negative 10, which is negative 700 over negative 20, which the two negatives do make a positive, and we're looking at 35. Okay, so maximum selling price looks like we want to sell whatever we're doing here for $35. I guess it was headphones. Now to figure out my profit, I have to now figure out f of 35. So we're going to substitute that 35 in every single place we see that x. Now these are giant numbers. I probably would not mental math this. I think I would just stick that all in my calculator. It's going to come out it's going to come out 6,250, which seems reasonable because it looked like it was a little bit above the 6,000 line. So that seems like a pretty reasonable y value. So to interpret, we would say something like the selling price of $35, I guess it's per headphone, that will give the maximum profit of $6,250. So that's what you're interpreting by reading that graph. So it is good to know the equation there to figure out the vertex, because on one like this, you can't actually tell where it's at. I mean, we have an estimate, but knowing the formula helps us get a more precise answer. Okay, how about you guys try this one in your notes? Again, hit pause, try it, and then come back and you can check and see how you did. Okay, so let's check it out. This time they're throwing a water balloon from a window. So it looks like they were here and they tossed the water balloon, it went up and it comes back down, right? And the height of the water balloon can be modeled. They give us this function here, and they want to know what's the maximum height of the water balloon after it was thrown. So we can kind of see it's right in here somewhere between 400 and 500, but we're actually going to do our calculations to get the precise answer. So remember, negative b over 2a. We always do that first to get the x coordinate of our vertex, basically the h value. So in this case, we have 160 over 2 times negative 16. Again, I see those two negatives. So that's going to simplify to positive 5. We're going to take that 5, we substitute it back in to get the y coordinate. So we got substitute that 5 in everywhere again. These ones are kind of some big numbers. I would probably just use a calculator. Make sure you're using those parentheses as you do that. And you should get about 450. So to interpret this, we would say the maximum height of the balloon is 450 feet and occurs at 5 seconds. So basically after 5 seconds, the balloon is 450 feet up in the air. Okay, so hopefully you did okay on that one. So I think we'll stop there, but that gives you an example and one to try on your own.